It has been announced that with GPT-4o you'll be able to read video, but it's not there yet unless you do this trick. It's really a shortcut, really. So what happens, or what you can do, is that you take a video and you put it into frames and you put it into audio. Now 4.0 cannot read video, but it can read images and it can also read audio. So this is exactly what we are going to do. If you want to do this with me, you'll find a link in the description where you'll get a link to a folder where you'll have first this starter file that you can see here. And as well, so this is my API key that I definitely need to hide. And as well, you'll be able to find a couple of videos of mine that you can give it a try. So this is really data for you to use and just to also try different versions of this. So let me hide the part of the API key and wait, where's the hiding part? Okay, this is odd. Let me update this and hopefully it will work next time because, okay, maybe I'm missing, aha, here you go. The toggle is not here. And this starter file has some libraries that you definitely need. Those would be, for instance, OpenCV, Python, this MoviePy, and the OpenAI. And as well, what you also require, and I'm using Google Colab, so you need to change the directory. And this is the one that I included, so this one is mine, but of course, feel free to change because otherwise it won't really work. And then you have the libraries specifically, and then what you would have, so after the libraries here, then you would have the model, in this case, this GPT-4o. This is where you kick off with the OpenAI library. So this is an important step. And you have the system prompt. Now, I won't, make you write a system prompt, right? So this is why I included it here, but it's basically the purpose. And the purpose was I'm not good at writing. I don't even like writing, but I do have a lot of video content and I guess a lot of people like reading. So what I would like to do is that I'm going to start taking some of my videos and using my tone, my pauses, my weird jokes and inflections, so on. And hopefully I can have this API do it for me. Take my video, take my frames, and, really build it. And therefore, this is the prompt, right? So you are creating a blog post based on a video, right, in the same style as the tone of the speaker audio. Complement audio with information from the images, detailing what the images tell and or do not. Let me actually change that. Tell or do not. Include code if available in the images and complement with leading sentences, commenters, and explanatory concluding sentences. Write in the first and second person like the speaker directly to the reader. So, me talking to you. This is an important thing. And then responding markdown. So this is so that you have a nice output. So let me get here the libraries, the directory, then I import stuff. And I'm going to start with this gradient boosting feature sampling. That is because I thought, yeah, you know what, this should actually be difficult because it's really more complex stuff, right? Then you have the model and then you have the prompt. And then that said, you can then move on to the video processing. And in this video processing, this is really the most important thing, right? So you need to create a function that processes the video. And there's really two steps here. The first one is the images part, so let's say the visual part, and the audio part. The audio part is fairly straightforward, and I don't think you'll have any difficulty understanding. The visual part is a bit more complex, but let's kick it off. And we define process video. So define process video. There's two inputs. It is the video path. By the way, the video path is this one, right? So fairly easy. And then what you need to have in mind is seconds per frame. So seconds per frame. I'm going to set it as default 5. And this is because like most of my videos is me explaining stuff. So I would then write something or do something or, share. So it's not like, within 10 seconds, the video changes drastically, right? So if you miss 10 seconds, you won't miss a lot. Of course, from the audio, you would, because I would explain stuff in the meantime. But it's usually, slides that have some animations or even the tutorials, right? So it's me writing, so it has a slower pace. So 5 seconds is okay. At the same time, have in mind that the more or the fewer frames, the fewer seconds per frame, then the more frames you have. And therefore, it would be higher cost because you are calling an API which has a cost. So let's continue here. We'll kick it off with the difficult part, which are the frames. So base, I'm going to call it base 24 frames. And this will be an empty list. This is where we'll store everything. And then basically, so we would get here or start by splitting the video path. So let me come here. So this is get the base path. And the way that we do it, so base video path equals 2, or better yet, comma and something, because using the function next has 2 outputs, os.path dot and then split text, and here we go, and split text, and then parentheses, and then we include here the video path. Here we go. And then we continue, right? So we start by opening the video. And then after we open, we get the total number of frames. So you see, when I'm recording, I can even have like 25 frames, 30 frames, 50 frames. So we kind of need to figure out how many frames we actually have in our video. And after we get the total number of frames, we get the frames per second. So get the frames per second, or FPF, frames per second, FPF. No, FPS, right? And then after that, we are going to calculate the number of frames to skip, right? Because every 5 seconds we take a screenshot, right? And our video, and I think with this one, okay, let's call it 25. Let's say it's 25 frames that I have in a given second. This means that within 5 seconds, there are 125 frames. Therefore, it will be like every 125 or 124 are skipped, 125th I save, and then I move on. So calculate the number of frames to skip. So this is the initial logic. So in order to open here the video, so open the video. So video equals 2. And here I use the CV2. And then video capture. And then here I simply include the video path. So step 1, get the total number of frames. So total frames equals 2. It is an integer. And then here video dot get and then I go to CV2 dot, and then it is cap, and then, so let me see if I can find something. So cap underscore, and then prop, hopefully, okay, not yet. Okay, and then frame count. Here we go. Let me zoom in here for a bit so that you can see it a bit better, and also me as well. And then the FPS, so this one equals video dot get CV2, and then it is the same, so cap, prop, and then FPS. And then total number of frames to skip. This is nothing but, so frames to skip equals to integer, and then it is the frames per second times the total frames. Here we go. Or better yet, FPS times, and then seconds per frame. All right, so we have, let's say 100 then, or we have 25 frames per second, we have 5, or I want every, 5 seconds. And so one times the other. So this is the number of frames to skip. And so current frame, we start at 0. So this is the initial step. And now that we have computed all of this, we kind of need to loop through and extract. Right, so while current frame less than total frames -1 colon, and here we go. So the first step is to set the position, and let me scroll a bit, of the next frame to read. And as well, we need to encode the frame as JPEG. After that, we convert the JPEG into base 64 string and append to the list. And then we move on to the next frame. So this is how we do. So we start off by setting the position. So video set. And then here what we do is we use the CV2 and then cap, and so cap, prop, and then position of the frames, right? And what we need to do is, okay, so what is the current frame? So first we get it, and this is clear, and then we encode it. And here we go. And what we do here is we do it like this because we don't want the first one. So buffer equals to CV2, and then emin code. So this is the function to encode the frame, and we want as dot JPEG, so JPG. Here we go, comma, and it is the frame that is included. And after that, what we need to, I'm forgetting something, right? So video set, this is clear. And we need to have this success, comma, frame. And you'll see what I do with success, but basically it comes from video and then dot read. So we read the video. And then if not success, I was forgetting about this, colon, we break, otherwise we continue. So we have here the frame because we needed to get it from here. We encode it to JPEG, and now we need to convert it. So base 64 frames, and then we append. We use the base 64 here, and with the B64 encode, and buffer. Here we go. And then we decode, and wait, I think I have parentheses too many. Wait, let me check. No. So dot decode, and then UTF-8. So this is how it works. Getting here an error. So it should come from here. So base 24 frames. And base 24 frames. No, base 64. Base 64 frames. Here we go. So this is correct. And then we move on. So current frame, and then plus equal, and then frames to skip. And let me just do a quick recap here, right? So first we find the position, so we set it, we read the video, and this will continue, right? So not breakpoint, right, but just break. Maybe the point is missing from somewhere else. Doesn't matter. We'll figure it out. We set the video, we read the video, and then we encode into a JPEG. We decode it and put it as our base 64, and then we move on to the next one. And then at the very end, video.release, and with some parentheses. And this is the step. So video is done, and then we focus here on audio. So you'll see that it is very, very easy. Let me align stuff. So this video should be here. So we do the while loop, we break, we release the video, and then we move on to the audio here. And we start by extracting the audio. And in general, it's more or less the same thing, but the big difference is that it is much, much easier. We start by figuring out which one is the audio path. And this is an F, and then we use base video path. And then instead, and I need to add here some curly brackets. Here we go. Dot MP3. So this is the initial step. We take the clip equals, and then we use video file clip. Here we go. Open parentheses. We include the video path. Here we go. And then let me just explain first. Then we are going to just get the audio, and then we are going to close the audio and close the clip. So this is it. And clip, and then what we do here, dot audio dot write and underscore audio file. We include the audio path. Here we go. And we set a bit rate equals 2, and 32K usually is okay. It won't be amazing by far. I'll give you a quick overview, but set it like this. Clip.audio.close, and then at the very end, clip.close. Now we get, or we should get, some statistics. So number of frames. Number of frames. and then as well, and audio. So this is what we include. So print an f string, extracted, and then length here, or better yet, curly brackets, length, and then base 64 frames, and then frames at the very end, and then print as well, and then with an f string, extracted audio 2, and then curly brackets, audio path. And at the very end, this is a function, so we return what we return, the base 64 frames and the audio path. Here we go. Now, we would then apply here this function, right? So how to do it? And so we have the function. Let me do Shift Enter. We now process the video. How to do it? Let me get here. So process video, video path. And how was our video path called? It was video path, all caps. And then the rest should be more or less the same. Here we go. So we process the video, and at the same time we store stuff, right? So we are smart people. So base 64 frames, audio equals this. Control Enter. And while this is processing, we can actually move on, because so I would like us to display what we're seeing and also listen to what we got. And so listen and watch the output. So because in the end, all of this will serve as inputs to OpenAI API. So it's kind of important. And here you go. So display handle equals to display, and this is basically like no customization whatsoever. Display ID equals to none. So this is the initial one. Now we are going to get the frames. So for image, and let me increase this. So for image in base 64 frames. And then here what we need to kind of do, we need to decode stuff. So decode image, and same thing. So base 64 with the B 64. Okay. And then decode, and then here image or img dot encode, and then UTF-8, UTF-8, and then display handle. Here what we do, so display handle dot update, open parenthesis. We use this image that we have imported way above, and data equals this decoded image that we have just created. And we set this width equals to, I don't know, 600. This is usually okay. And we're going to go through each one. So each time, so time dot sleep, and here we do 1. Now this is for the images, and we have invalid syntax, and I see that I have a missing parenthesis. Let me try again. And okay, so this is extra. This is an extra D, or better yet, decoded. Sounded much better than decode image. Let me do Control Enter. Oof. Okay. Encode. Okay, how should this be? Let me check. So encode. encode. Oof, rough. Not yet. So non-type object has no attribute update. Okay, so this is worse. So display handle dot update and then image data equals decoded image and then width equals to 600 with 2 parentheses. And I think, okay, so we have definitely 60 or 34 frames. So this is working. And let me actually explore and see what is happening. So base 64 frames. Let me see if I can get an output here. And data equals decoded image. We set the width. Image.encode UTF-8 with the B64 decode. And we use this base 64. So stuff looks encoded here. So everything looks okay. But somehow this display is not working. And okay. Let me go ask here our friend, see if it can help us a bit. So Control A, Control C. And let me zoom in here for a bit. Okay, let me do enter. And here's the straightforward version of your code. Yeah, let me just do Control C. And then see if it works. Haha. Wait. Let me see what was the issue. Because now I'm curious. So display ID none. Display ID. Okay, put to true. Also fine. For image in base 60. Okay, so I can take this, whatever. Control V. And now I can have a look. So for image in base 64 frames, decoded image equals base 64 B64 decode, IMG encode UTF-8. Wait. Display underscore handle update image with, maybe it was the true part. Yeah, maybe it was definitely the true part. Which also makes sense, right? If I'm having the display handle, I should set the display ID to true. So this was my fault, also adding here with the nice comment. And now I'm going to leave here so that you can also have a preview. So these are all the frames that we got. And at the same time, audio, and then audio path. Here you go. And, or basically just audio, right? So, because that is what we got. And at the very end, I'm just going to listen to 5 seconds. I don't think I can even listen because I don't have I'm going to put my earphones basically. And yeah, so you can see all of our things. And let me do Control Enter. So we'll get the images. And so that at the end, I'm going to try to listen here to my audio as well. And yeah, this is like the big bulk where we actually focus on the video processing and so on. Very quick debugging as well. That was an important step. And then what we will do is that we'll actually move on to our OpenAI and how to actually, use it. And here would be the audio.
Video, we saw that observations are
hopefully you can hear it, but it's basically, it's a bit weird, right? So it's
model.
not.
Do you recall that? it
a
actually make
proper
sense?
way, right? So it feels like a bit,
if you answered yes
you know, it's
to
scratching.
both of these questions, then feature sampling.
But never mind. So this is how you can display the audio. I think you can increase the bit rate to improve the quality. I think that's how it works. But never mind. Let's focus here on the OpenAI API. And I'm going to do this in 3 steps. We're going to focus first on the images. We're then going to focus on the audio. And then we're going to do the 3 things together. So stay tuned. The way that we interact with the API, in case that you're not familiar, we use this client, and this was something that we started all the way at the beginning, right? So this is where we use the API key client, and then they have this endpoint, which is chat.completions.create, open parentheses, and then here we start. So model equals to model, comma. And these are the messages. And this is very similar to interacting with ChatGPT. It's under a list. We start off with the overall situation. So role here is the system. And what we include here, so this is the content. The content would then be here the system prompt that I created above. And I go here, so prompt, and this is the initial one, comma. And then we have as another role, so this would be the user, and this is the stuff that would change. So role, user, comma, and then the content. Here we go. Content colon, and then here we would start with another list. Okay, I don't know why that popped, but okay. We would kick off first. So these are the frames from the video. And okay, let me add here a P for system prompt. And so comma, and then we would add, so we basically map everything. So an asterisk map, and then lambda, and then x colon, and then we specify here the type. So type, go to the right, and then here is image URL, and then comma, and then the image URL, go to the right, colon, and then this is another dictionary URL, and then go to the right, f-string, and then the way that it works is this data slash or colon image slash JPG, so JPEG, and then semicolon base 64. And I know that, this may seem like overly complex, I guess. And I guess like, yeah, in the end, you're a bit, of course, right about all this because it's complex, right? But you're welcome to just, copy this if it is a bit easier. But let's continue. So comma here. And it's even likely that, I actually make a mistake in the end and just go to chat GPT and, just get it over with. And okay, let me actually go back because I think I'm doing something wrong. So the data image, JPEG, and then base 64, comma, but not really here. I include here the X, and then here, this is when I actually close. Then I comma here, and then the detail And then here I set it to low. Go to the right and go actually a couple of dictionaries here, because now we go away from the lambda, and this is the input, which are the base 64 frames. And so this part is complete here, right? Let me put a comma here as well, so that we can have a look. So comma here, and this is set to here as well. So comma as well, and then temperature equals to 0, because I don't really want to have, any problems here, or I want very little creativity. Display, and then mark down, and then we take our response dot choices, and then we get 0, and then dot message dot content. And let's see if I get any spelling mistake over here. And here we go. Let's see what was the problem. Expected an object but got a string instead. Type invalid request error. Param messages 1. Ugh, okay, cannot really figure this one out. Okay, but I can try to have a look. So lambda x type image URL, and we have the aha. So I'm seeing something here. Image URL. Let me give it a try, because this one is different. And let's hope it was just this. Boy, it would be fantastic if it was this easy, right? But nothing is really popping. Fantastic. And yeah, this doesn't really take a long time, so it's usually like quite fast. So it's nothing that you need to overly concern about time. I'll guess 30 seconds max. Also depends on how many images you're including and so on, like what kind of outputs you're getting. And it's not really displaying in a nice way that I expected, but let's have a look. So hey there, today we're diving to the concept of feature sampling and boosting. Let's break it down step by step. What is feature sampling? Feature sampling is a technique used in machine learning to select a subset of features for training models. This helps in reducing overfitting and improving the model's performance. So very, very good. In the context of boosting, feature sampling plays a crucial role. And it continues. So it's definitely extracting stuff. It's definitely good, but it's not me, right? So this is not like, it doesn't feel like this is something that I would write. And this is why we need the audio part. And the audio part is really, really cool. Let's start with the transcription. Let me also remove the headphones here. So transcription. And this transcription here equals to use the client dot audio dot transcription dot create model equals to, we use the whisper 1, here you go, comma, and then we use the file equals open, and it is the audio path, or just audio. Let me check, because now the audio is kind of here, but I know the audio is named like it should, and then it should be audio path, or just no, open audio. This is how we set it. And then we have this RB. This RB is read binary, and this works when something is off. This works when you're trying to read stuff that is not really text, and this is where you would then include this read binary. Okay, this is not 100% working here. So let me take this, and I'm going to include here another parenthesis. So transcription. And let's say that I wanted to print the outcome. So I could print the transcription, and then dot text. This is actually enough, or almost. Audio object has no attribute transcriptions. And audio, so it should be audio.transcriptions. Let me try again. And now it's actually working, apparently. So all good. So this is where we actually have the transcriptions, and you could see it here as well. And I could add, by the way, so plus, and then let me include here. Wait, where is my slash? So slash n slash n. Here you go. And this would make it in a nicer way of viewing. And in the meantime, right, so we have here, actually did nothing. Okay, never mind. Let me take this out. We have the transcription text, and now we would take this transcription here, and then what we would do is that we would include it here as a part of our parameters for the API calling. That's it, right? I really don't want to go through having to write all of this. Let me do Ctrl+C. And let me do here Ctrl+V. And system prompt continues to be the same. And then we have the role, the user, and then we have this content, right? And this is where stuff starts to change. So let me delete this part over here. And we have the content, and then we have here the type. And let me put here inside dictionary type, it is text, and comma, and what kind of text is it? And I go to the right, colon, and then with an F string, the audio transcription is, and then I would just go and kind of like include here transcription.text. And here you go. So transcription.text. Here you go. Let me do Control Enter. This should be more than enough. And temperature set to 0. And yeah, this is it. And we then move on as we put everything together. And this is really like the cool part and why you're actually here, right? Yeah, so again, we wait our seconds. In the meantime, I can actually start preparing. Let me get this as well, because this was the lengthier one. And what I need here to include is that I need to include this part as well. So these are the frames from the video. And then we have here the map, the lambda, we have all of this part, this base 64. And at the very end, then we add here the type as well. So I come here and okay, I'll go to this output in a bit. Let me just copy this part and Ctrl+C. And I'm going to add it here. Before I get to it, let's have a look. So understanding feature sampling in gradient boosting, and it goes like, in the previous video, we saw that observations are sampled for each iteration or model. Do you recall that? It did actually make sense. Well, if you answered yes, to both of these questions, then feature sampling will be as simple as frying an egg. This is very me, right? If by the end of this post you're like, okay, I understood the previous one, but this one was terrible, feel free to hit me up. I'm happy to answer any questions and I'm here to help. Very good. And let's dive into the summary of the first iteration. Imagine we use predictors, x1, x2, each having 50% importance. Very cool. And then we also have complexity of boosting and feature sampling. It adds an example. So this is cool as well, right? So not only it's taking from what I have written, right? So from my audio, it's also adding something. So this is cool. And then we have a general conclusion. I hope you enjoyed this post. That is clear how gradient boosting works. These are the two main things that are happening, boosting and feature sampling. Now, I don't really dare to do all of this simultaneously because it's just too complex, but I hope that this simplified view enables you to understand the intuition behind these features for gradient boosting. Again, does feel like me. And therefore, we can actually continue here to this part. And we are, so parentheses not closed. So this could be a potential issue. And here as well. Also this one not closed. Okay. You know what? Control C. And I'm like, correct the parentheses in this code. Here we go. So I don't know, like when you start, just copy pasting stuff, of course you get a few things that are wrong, but this becomes much easier. Let me do Control Enter, and then we'll get our final output. One thing that may also be interesting for you is, okay, how much does this actually cost, right? It's very affordable. So I think that for these 3 runs, because we did, actually it's 4 runs, right? Because we have 3 times the 4.0 and 1 time the Whisper. It's like 10 cents, 15 cents maybe. So it's definitely affordable. And here you go. So one thing that I definitely need to focus, so I added as a system prompt to include where was it? Yeah, to include images, right? So include, if available in the images, and complement with leading sentences. So this is okay. But what is happening here is that we're getting the images, and personally, I like this style, right? So it's really detailing what is happening, and I complement this with my own images. So this is very good. It's also very similar to something that I would say it's also written in a very orally and pragmatic way. So this is also very cool. These images here, don't care so much. I guess this is really part of prompt engineering part that needs to be improved. But this is very good, right? So this is excellent, and it's really about complementing. So I would take this text after I have improved the prompt engineering. I will take some of my images, and then I'll just build something, and I can build now whatever I want. So ebooks, blog posts, whatever I wish in a different medium. So if this is something that you have enjoyed, let me know. Reach out, answer in the comments. I know that this was a long tutorial, but this is also a long process, right? To go from 0 to actually this, it takes time, and it's not complete, as you have seen. Hope you enjoyed it, and I'll see you in the next video.